We're dealing with the question, p of x is divided by x squared minus 3x plus 7. It yields a quotient of x squared plus x minus 1. Given that p of x divided by x over 2 has a remainder of 29 and p of x over x plus 1 has a remainder of negative 16, find the general remainder r of x in the form of x plus b. So, what sort of question do you reckon we're dealing with here? A remainder theorem. Yeah. Okay, whenever we're dealing with remainder theorem, guys, what we're typically looking for is we're looking to arrange our polynomial p of x in the form of a quotient, q of x, multiplied by a divisor, d of x. And in this case, because we're dealing with unknowns, rather than just plus r is going to be, or the remainder is going to be a function of x as well. So given what we know here, do we actually know what p of x is? No. But we know what the quotient or the divisor is. So it's divided by this guy. So d of x is actually that guy. And the quotient, q of x, is that guy. So we actually know d of x is x squared minus 3x plus 7. And q of x is x squared plus x, take 1. And obviously our r of x is unknown, isn't it? So if we put this all together, what we discover is that p of x must be equal to x squared plus x, take 1, times x squared, take 3x, plus 7, plus r of x. Now, r of x, what sort of form are we expecting it to be in? Ax plus b, because it tells us in the question. Now, first part of the question has been done. We now turn our attention to these remainder parts. So it says if we got p of x and we divide it by x take 2, we get a remainder of 29. Similarly, if we divide p of x by x plus 1, we get a remainder of minus 16. So the next step in here is what we need to do is build two equations using the information we have. We have a general equation which contains two unknowns. We have two pieces of information that allow us to build two equations. So what do you reckon we're going to do, Leishman? Yeah, we're going to build two equations so then we can solve it simultaneously. So, given, let's say, given x take 2, we could set the k of this to equals 2. Hence, p of 2 is going to have a remainder of what? 29. So I'm just going to sub that in. So I'm going to say p of 2, which is 29, is going to be 2 squared plus x, plus 2, take 1. Then we're going to get 2 squared, take 3 times 2, plus 7. And here's where I messed this up when I was doing my own practice. 8x plus b, what do I need to sub in here? 2. Yeah, I forgot to sub in 2. It really spoiled my day. Bingo. Okay, now to this point, I could evaluate what's in the brackets, but it's a point of contention because I always mess this sort of thing up. So what we do is we use our calculators, and I'm going to show you how to use your calculator in such a way that it reduces the amount of error you're going to make. So we're going to go into run matrix mode. And then I'm going to show you how to key this in such a way that you won't mess it up. First thing we want to do is just clear the memory because we're on a new question. Next thing we want to do is we want to throw in, we're dealing with x equals 2 to begin with, so I'll go 2 into variable x. Next, on the left-hand side of my equation, I have 29. So I'm going to go 29, subtract. Then in the brackets, I'm just going to key in, where's my green? I'm going to key that part into the calculator. So in parentheses, it's going to be x squared plus x take 1, open parentheses, x squared take 3x plus 7. Boom. So it's one-liner. I get 4 on the left is going to be equal to 2a plus b. And that's going to be equation 1. Next equation. We need to build a second model. 2 unknowns, so we need 2 equations. So we're going to go, given x plus 1, we're going to get a k of minus 1. So p of minus 1 is going to give us a remainder of minus 16. Hence, minus 16 equals okay, that's set up so far. Now to save myself time and error, I'm going to go back to my calculator. I bring my cursor back to the top. I change this minus 2 to a negative 1. And then from that negative 1 I hit execute and it will update all of my values for me. Yo.
Negative 16 take.
Bingo. That would have ruined my day. Back to the top. Go. When x equals minus 1, we get an output of minus 5. So, building my second equation, I get minus 5 equals minus a plus b. And here's my second equation. Solving simultaneously. I cue the marker that I'm using my technology to solve this simultaneously. You don't get marks for that if you did it by hand. Just use your technology. That's what it's there for. And we simply throw it in. So, we go. Menu. Solve simultaneously. We have F1, 2 unknowns. And then I input it in general form. So it goes ax plus by equals c. So I'm just going to go 2, 1 equals 4. Next one, minus 1, 1, take 5. And I think it's like 3 and minus 2. So there's your A, there's your B. So putting this together, what do we say our general remainder is? Rx equals?
3x, take 2.
Seem reasonable?
Yeah.
So the steps involved are, for these sort of questions, always model what you have. This is a really daunting question because it doesn't tell you to do this form, you just have to know based on the information it gives you. So I always recommend write it out as px equals qx times dx plus rx if it's a general remainder. From there, state your qx and your dx, sub them in, then read the question again, see what it's actually given you. Sometimes it will give you remainders, other times it will actually give you factors. When it's factors, it's not going to equal a number, it will equal 0. And from there, count how many unknowns you have, and then figure out how you're going to generate enough equations to solve for the amount of unknowns you have. Sound reasonable?
Yeah.
Awesome.